let's keep cooking here. All right. So what we want to do here is we want to introduce our first object. So we're going to talk about something called a string. Okay. First of all, notice it has an uppercase letter in front of it. Observation you'll see is most class names. We'll talk about that in a second, but we've already introduced the keyword class. We talked about the difference between C and C++, how C++ introduced that idea of a class. Most class names start with an uppercase letter. It's not a rule, it's a naming convention. Okay, most class names start with an uppercase letter. So typically, if we see a word that starts with an uppercase letter, chances are it's the name of a class. Okay? So string is going to be our first object type we learn about. So I mentioned earlier about we have two different types of variables in Java. We have primitive types, which are types that are built into the language that can only hold a value. And then we have this other kind called object types. So an object type can hold 0 or more values and can potentially do more. Okay? Now what do we mean by the do more part of it? So we need to talk about these things called methods. And methods are synonyms for functions, subroutines, etc. They all mean the same thing. Historically, I think, did I mention the difference between procedures and functions at some point? Is that not ringing a bell to you? Back in C, the C programming language, we had two different types of these guys. One was called a procedure. Procedures did something but did not return a value. Functions did something but did return a value. So, at the end of the day, they're both the same kind of animal, just one of them returns something, the other one doesn't. Okay? In our more modern languages, we've now called these guys methods, where methods may or may not return a value, but they always do something. Okay, so this idea of procedures and functions has kind of been compressed into one animal, and now they're just called methods. Sometimes people still call them functions. That's fine. I don't hear people calling them procedures anymore. So usually functions, methods are used synonymously. They mean the same thing. But at the end of the day, what are these guys? These are reusable chunks of code that we write once and can call multiple times. Okay, so let's see this as an example. I'm going to go ahead and I'm going to write a function here. Well, actually, before we write a function, let's do some math to do something. Let's say that I want to get the factorial of a number. All right, so for instance, 4 factorial is equal to 4 times 3 times 2 times 1, right? It's like a math thing, okay? So if I want to calculate 4 factorial, then what I might do is I might say, I know I need to go through 4 times, right? So I might say 4 int I is equal to 0, I is less than 4, I plus plus. Actually, why don't we mimic it and count down? So we'll start I off at 4. We'll keep going as long as I is greater than or equal to 1. And we'll say I minus minus each time. So we'll go 4, then 3, then 2, then 1. Now each time through, we need to accumulate our answer. So that means we're going to need a variable to build our answer. And we're going to have to remember our ongoing answer. So I'm going to create an integer called answer. We're going to start this guy off at 1. We don't want to start them off at 0, because if we start them off at 0 and we multiply it, we're going to keep getting 0 back out of it. All right, so we're going to accumulate multiplication inside of a variable, and we're going to start that variable off at 1. So we're going to say answer is equal to answer times the current value of I. So the first time through I will be 4. So answer is going to end up being 1 times 4, which is 4. Next time through, it'll be 4 times 3, which is 12, so on and so forth. All right, and then in the end, we'll just do a system.out.println answer. And this should show us 4 factorial. If I want to do 5 factorial, I can put 5 in there, and there's 5 factorial. If I want to do 21 factorial, what happened? Get a negative number. What's the biggest value that we can fit into an integer? It's a byte. A byte is negative 128 to positive 127. What's an int? 32 bits, plus or minus 2 to the 31st. Right, that would be the precise answer. All right, roughly plus or minus 2 billion. Okay, is the range. So
if you change that from an int to a long, you might see the
maybe,
yes.
maybe. So we're going to give it a shot. It shouldn't make a difference. Nope, still didn't fit. Still a negative number. Why did it become negative in the first place? Let's try to understand that. I'm just gonna cut this out of here for now. I'm going to show you an example. We're going to say byte B, and what did we say the biggest byte number is? 127. So byte B is equal to 127. We'll say system.out.println B. I'm going to say B++, system.out.println B. What will print out? Well, math says it should print out 127 followed by 128. But what's actually going to print out is 127 followed by negative 128. We overflowed our number. When we added 1 to it, this is a binary. This has to do with how numbers are represented under the hood. So, binary overflow. So the biggest positive number that we can represent in binary is this: 1, 4. That. This is the ones place, 2s, 4s, 8s, 16s, 32s, 64s, and this is a positive. All right. Now, if we add 1 to that, okay, let's look at what happens. So we have to start. I'm gonna just give me the placeholders for right now, so I can get out to that part. 1 plus 1 is 0. Carry the 1. 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 0. Carry the 1. 0. Carry the 1. 0. Carry the 1. 0. Carry the 1.
Now you got to carry the 0.
Ah, we have one more carry.
Yeah, so now because it's a 0, it's that first one is a placeholder, so you have to.
So this is our sign.
Yep.
So this is 0, carry the 1. Now it's a negative number. This is the negative representation of 128. It's stored in what's called 2's complement form. All right, so you flip all the bits and add 1 is how you get the number. But in any case, That's what's happened. This was the biggest positive number we can hold. We tried to add 1 to it, and we ended up with this. Make sense? That's why it went negative. But now, so what's interesting about this, if I just show this as a quick example, let's say for byte B is equal to negative 128. Actually, let's just do it this way. Byte B is equal to 0. We'll just start off with that. And then we're going to say while true, system.out.println B and B++. So this is something we would call an infinite loop. Generally speaking, infinite loops are bad. Because by definition, infinite loops are infinite. All right? Now, the thing is that we would expect at some point this guy breaks. Because eventually we run out of space, but it's just going to keep looping back to the negative side. So if I run this, it's just going to keep cooking. Make sense? So we're seeing it count all the way up to 127, then go back to negative 128, negative 127, negative 126, negative 125, negative 1, 2, 3, 4, all the way up to 127, back to negative 128. Over and over and over again. All right, so this is a loop that just keeps spinning as long as this Boolean expression is true. First of all, is what I have highlighted there a Boolean expression? What's the definition of a Boolean expression? Any expression that boils down to a single value of true or false. All right, so we've seen a really scary looking Boolean expression at the beginning of class today with all those ors in it. Okay, this is a very simple looking Boolean expression, so simple in fact that we might question whether this is in fact even a Boolean expression. A Boolean expression is any expression that boils down to a single value of true or false. What's the value of the guy I have highlighted? True. Is that a single value of true or false? Yep. Pretty bare bones Boolean expression. That is a Boolean literal. True is a Boolean literal, just like the number 3 is an integer literal. Okay? So, now the question is, are infinite loops always bad? Short answer is almost always. Every now and then you might do something that is would benefit from having a infinite loop that you then break out of. So while I'm saying that, let me show you something here. We have a couple of ways of getting out of loops. So here's a loop. This is our standard loop that goes from 0 to 9, incrementing by 1 each time. But we're asking a question in here. We're saying if I is greater than 5, break. And what break does, this is a comment, break breaks out of this loop. We might even say breaks out of the closest loop. Because if you're in a loop inside of a loop, you're only going to break out of the inner loop. Okay, this will break out of the closest loop. So that means we won't loop up again. We won't continue on. We literally dive out of the loop. Okay? So this is going to print out what? This is going to print out 0. Is 0 greater than 5? No, so it'll print out 0. 1, 2, 3, 4, 5. Is 6 less than 10? Yes. Is 6 greater than 5? Yes. break. So this will print out 0 to 5. Make sense? The other one, let's just do it this way. We have another directive called continue. Continue says, skip this version, skip this iteration through the loop and just continue on to the next one. So this will print out 0 through 4. Then on 5, it's just going to say, oh, move on to the next counter. You'll jump right to there. Won't do anything else inside the code. So now it'll print out 6 to 9. So we'll skip 5. Make sense? All right. And here's kind of a trick. So we have another, and this is a precursor to what we're about to talk about with methods. There's another keyword called return. The return keyword makes a method immediately end. Now we happen to be inside of a method right now. We haven't talked about it very much, but we're currently sitting inside of a method called the main method. When I say return here, that method dies. Do not pass go, do not collect $200. Okay. Dies. It's a Monopoly reference. Have you played Monopoly? You don't play Monopoly? Well, not enough RAM?
What?
Yeah. not enough 4 gigs of RAM, you can't play Monopoly?
No, I never played any game. Most of the time, I'm not much interested in games.
Not even Monopoly? Boardwalk, Park Place? Terrible. That's where the do not pass go, do not collect $200 comes from. All right, so in any case, return will make this entire method end. So from our perspective right now, this is going to print out 0 to 4 and then end. Now what I'm going to do here, though, is we're going to do a system.out.println hello, just so we can see the difference here. If I say break, it's going to do 0 to 4 and then hello. But if I say return, it's just going to say 0 to 4. Because the method died. It's over. Finito. All right? We never get here because we ended it all right here. Okay? So this is a handy way of getting out of a method. So if I'm inside of a loop, inside of a loop, inside of a loop, and I just want to end it all, this gets me out. It's not a common practice, but it is something that we can use sometimes. Okay? We're going to commonly use the return statement to return values from our functions. All right, we're going to see that here in a second. But I wanted to show you some ways of manipulating loops. Now understand, if you didn't know about the break statement, for example, if you didn't know about this, you could just make this an else. And instead of breaking, we could just short circuit our loop. We could say I is equal to 10. So we're going through here, 0, 1, 2, 3, 4. Is I 5? Yep. Let's go ahead and set it to 10. The next time up, 10 becomes 11. Is 11 less than 10? No. We'll fall out and hit hello. So instead of using break, we just messed with the math to make sure our loop broke the next time through. We short-circuited the loop. That make sense? Same thing. Break is cleaner. Break just says, don't make me do any stupid math to get out. Just get me out. All right? But if we didn't know the break command or we had forgotten it or something like that, we can certainly accomplish the same thing this way. Make sense? All right. So let's go back to our factorial dealie we had here. All right, so we had our answer. We were doing 21 factorial. We understood why it went to negative, right? So let's go back to like a 6 factorial. All right, so we're finding it handy to calculate the factorial of different numbers, right? But every single time I want to do that, I have to modify my logic. So what we're going to do is we're going to take this logic and we're going to drop it into a function. Okay, so I'm going to write another function down here. So notice that here's our class driver, and here's an opening and closing curly brace in here. And for us right now, we're going to give a pre-definition of what a class is to us right now. This is a collection of methods. That's our world we're in right now. So inside of a class, we have one or more methods. We'll always have this first method, main. All programs begin and end with main. All the way back to the C programming language. It began and ended with main. Okay? So whenever we start our program, it's always going to go right into this guy and start right here on line 1. Start cooking. But we can optionally have additional methods in here. All right, so important thing is don't put another method inside of an existing method, and make sure all methods are housed within the opening and closing curly braces of our class. So we're going to put our second method right down here. You could put it before main if you wanted to, but usually you put main at the top. So I'm going to start it with the keyword static. For right now, trust me, put static there. I will definitely spend a lot of time explaining static, but just not right now. Okay? It's extremely important, actually, static, but for right now, it's not on our radar. So we're going to always start our functions right now with static, or start our methods with static. Now, the next thing that comes when we're defining a method is the return type, the kind of value that this method should produce. Now, methods that act like procedures, methods that do something but don't actually return a value, should put void in there. Notice here that main has a return type of void. That means main does not return a value. Main does stuff. We see it doing stuff right here, right? This is stuff. But it doesn't actually spit a value back out. Whoever calls main, the Java virtual machine, isn't expecting main to give it any response. It's just expecting main to run off and do its thing. And that's fine. Historically, in older languages like C and C++, we had functions and procedures. Procedures were like main. Did something but didn't return anything. Functions were like factorial. We're going to do something and we're going to spit the answer back out to you. So after we calculate factorial, what kind of answer would we expect? An integer, a number. Factorial of 4 is 24. So if I pass in a 4, I expect it to do programming magic and ultimately give me a 24 as an int. So our return type for this guy is going to be int. We'll call it factorial. Okay. Every single method has this is called a parameter list. Has an opening, closing parentheses on it. Now, you can have methods that do not take any parameters, but they will always have a parameter list. It just may be empty. Okay, so 100% of the time, methods will have an opening and closing parenthesis. In this case, in order for our factorial function to work, we have to provide it with a number. So for instance, we would like to pass the factorial method the number 4 and have it give us back the number 24. We would like to pass it to number 3 and have it give us back a 12. Make sense? So we need to require one parameter, and that parameter should be an integer. So let's call it int num. You can call it int num, int a, int elephant. It doesn't matter what you call it, but whatever you call it here is how you'll refer to it inside the method. So this guy's going to take a single integer. He's going to do some stuff with that integer and ultimately spit out an int. So I'm going to steal our code from up here, paste it in. Instead of 6, I'm going to put num in there. And then instead of printing the answer, I'm going to return the answer. Understand there is a difference between printing something and returning something. All right? Now, well, here, let's do it this way. I'm going to say int answer is equal to factorial of 4. System.out.println answer. Okay, so I am creating a variable here named answer of type integer. This is a variable definition. The scope of this variable is global within the main method. Okay, and this guy is equal to a value. What value? Whatever value is returned by the factorial function when I pass it the number 4. So when I pass the factorial function the number 4, 4 will come in for num. We'll start answer off at 1. We'll start I off at the current value of num, which is 4. Do all our math. Ultimately get a 24. We're going to return that 24 right here. It's going to come firing out of the factorial as an int. So this guy is going to boil down to, in this case, a 24. And we're going to store that value inside of answer. And then print it out. And there's my 24. Next line, I'm printing something out. What am I printing out? I'm printing out whatever factorial of 5 is. I'm not storing the factorial of 5 anyplace. I'm not putting it in a variable that I could then use later, but I still get its value. Okay? Factorial of 5 is going to boil down to 120. I'm not putting it anywhere. What am I doing with it? I'm printing it. So it's going to spit out to the screen and then it's going to be forgotten. Because we haven't stored it anywhere. As opposed to the factorial of 4, we stored it inside of a variable called answer. So I printed answer here, but I still have access to answer right here. I can go and print it again if I want. That guy's still around. Okay, but the factorial of 5, I chose not to put it anywhere, so I'll have it just for that moment to print it, but then I've lost it. Okay, because I chose not to remember it inside of a variable. So there's our 24, 120, and 24. Make sense? So notice here that we wrote this chunk of code one time. And now we can call it multiple times, passing it a different input and presumably getting a different output based on the input we gave it. This is handy. So now we can get the factorial of a whole bunch of numbers. So if I want to print out the factorial, let's steal this line real quick. So for int I is equal to 1, I is less than 10, I plus plus, I can print out factorial of I. So this is going to go through, it's going to print out the factorial of 1, the factorial of 2, the factorial of 3, the factorial of 4, all the way up to the factorial of 9. Make sense? So that's the power of functions. Okay? We've recognized something that we might want to do more than just once. Therefore, we're going to write a function to do it for us. Okay? And it's the same code we had up here in main a few minutes ago. So we kind of architected it in main and then moved it into this function and just modified it to work off of a parameter that's being passed in rather than a hard-coded number here. Num is a variable. This guy could be 4, this guy could be 5, he could be 6, he could be whatever was passed in up here. So an important thing to notate here is this down here is a method definition. Okay? Similar to a variable definition. This is when we are defining a method. This is an untapped resource.
So it is always we have to keep it down or no?
You could put it anywhere inside here. You could put it before main if you want. You just can't put it inside of main. That goes off what we said here. A class is a collection of methods. I can have 5,000 methods in here. It does not matter what order they're in. Just make sure you don't put a method inside of another method. Okay? They all need to be separate inside of this garbage bag that's a class. Okay? Now, for example, what will this program do? Nothing. All programs begin and end with main. What does main say to do? It says to do nothing. I have this beautiful function I wrote down here, this beautiful method called factorial that I never use. It's fine. That's the definition of the method. It's there if I wanted it. It's there if I needed it, but it's an untapped resource until I use it. Make sense? Alternatively, right here, I am making a call to a method. So just like the difference between a variable definition and then using a variable which then gets resolved to its value, this is a method definition. Here I am calling upon a method, passing it the appropriate number and type of parameters, and it resolves to the value it returns. Make sense? Put another method in here. We're about to introduce strings anyway, so we'll just do this. We'll see if you were paying attention. Okay, what will the output of this program be? Well, so let's go down the pathway of the mistake. How many hellos? How many times does this loop go through? 10 times. 0 to 9, right? 10 times. So this loop says do something 10 times. That's what that guy says, right? Right? This is our counting loop. Do something 10 times. What are we doing each time? We're doing this. What's the output of this one time? So it's the result of print something? What's the result of print something? S is the input. So what's the result of print something? Remember a few minutes ago I mentioned that there is a distinct difference between returning a value and displaying a value? Does print something return any value? No. Factorial did. Factorial returned a value here. Factorial advertised that it was going to return a value. Print something advertises that I will not be returning a value. Nada. Expect nothing from me. And in fact, we followed through and we printed something here, but we never returned a value from print something. All right. Notice this little red underline here. Why is Java not happy about this? What does system.out.println try to do? Tries to print something. What are we trying to get it to print? Yeah, everything I've highlighted. What are we expecting from that, what I have highlighted? That guy is a function being used, correct? Not defined, but used. And when variables or functions are being used, they resolve to their value. What does that guy resolve to? Oh, we advertise it. It's not going to resolve to anything. In fact, we didn't return anything. He prints something. Okay. Yeah, this guy does not send anything back. He takes in a string, he displays it to the screen, and then he just sits there and smiles. That's it. Nothing comes back from this. So notice the println method here is a little bit upset. He's like, I cannot print something from a return type of void. The method print in the type is not applicable to argument void.
If we change the type to string.
You want to change this to string? Okay. Well, then it'll stop yelling up there, but now it'll yell down here. Because now I've advertised that I'm going to return a string, but I never did. I am printing a string, but that is very different than returning a string. Make sense? Returning a string hands it back to whoever called this function. Returning a value gives it back. If I don't return a value, nothing comes out of this. Okay? Well, so. Oops, sorry. What about this? Like, oh, I have a return statement there.
You're not returning it to me, you're not telling it what you're returning it to.
Well, I'm not telling it what I'm returning.
Yeah.
I'm just returning. And what did we say return does? We introduced the return statement a few minutes ago. Method dies, right? Yeah, this guy I'm just killing it off. Okay? I don't have anything after it here that I'm returning, right? I'm just killing it. Like I'm adhering to what I promised. I promised you that I would not return a value. I didn't promise that I wouldn't die. Okay? I'm keeling over. I'm done with my stuff. I'm going to return. Truth be told, that if I don't put return here, it effectively happens anyways because I'm out of stuff to do, right? All right, but punchline is return does not require a value. Return by definition makes the method end. If I happen to provide it a value, then it'll actually return that value. So what if I do this? What if I say return S? Now he's pissed off.
Looks like you're void. I mean,
Yeah, I'm trying to hand a value out of something when I didn't advertise that I would. Java's like, hey, wait a minute. You told me you weren't going to give me anything. You said your return type was void. And now all of a sudden you're trying to shove this string down my throat? Make sense? Okay, so Java, and this goes back to when we talked about, when we introduced Java, we talked about how Java is protects us from ourselves. So Java has a lot of constructs built into it that keeps us from getting into trouble. We can almost think of Java like the Microsoft Vista, the Windows Vista of programming languages. It'll just keep screaming at us until we finally stop screwing up. All right? So, but understand also that we are working within Eclipse. So Eclipse kind of has a feel similar to like Microsoft Word. It'll underline things that you screw up on. Native Java, if you're doing this from command line, you're not going to get the nice little red squiggles. Right? It's going to be like you're working in Notepad. Okay, so this is more of a handy tool for us. Don't expect, especially in the IT world, where a majority of your programming very well might be done remoted into a micro Linux kernel running on a router or something like that. Okay, you might be writing some sort of software to deal with log files or something like that. So you would wish that you could work in an environment like this, but chances are you'll be working in an environment more like this. Make sense? So you're not going to get the nice underlines here. So, this is a C program. So as an example, I mentioned that all programs begin and end with main. So this is a C program from 1968, let's say. Here's our main. This guy takes two parameters. We won't talk about those right now, but this is main, and this is where the program begins and ends. It so happens that in C, main returns an int. In Java, it returns a void. And that's because historically, when you have commands like this, we're running them from the command line, we might want to know whether or not it succeeded or failed. So it's pretty common for a program to return an error code. Okay, that's why historically C, which was made for writing operating systems, was this. But this is, this is C code. So when we look at it at a glance, it maybe seems a little intimidating. But if you look at it closely, what are we doing? I'm defining a variable of type int called input fd. This could be called A or B or C. Okay, so I'm defining several of those in one line. Here's another variable of type s size t. That's a struct. Remember I was talking about structs? And that's one of those guys. This is an array. We talked about those, I guess. And then here I'm doing a couple of things. Here's a while loop. We talked about while loops today. All right, this thing's doing operating system input output stuff. Okay, so this is this file copies one file and outputs another, outputs a copy of it. That's what this guy's doing. It's not doing any rocket science stuff, but looks scary. Right? So what do you suspect that line does? It prints ouch. That's our error checking from my 450 class. So that instead of system.out.println, it's printf. That's the C version of that. All hard programs are made up of a bunch of easy parts. Make sense? If we just look at this as a whole, we might say, okay, well, that's a lot of scary crap. I'm going to go to lunch. When you actually stop and look at it, it's like, okay, well, they have some weird looking variable types. But I pretty much get what's going on here if you were to walk through it. It's not crazy stuff. What are we doing? We're opening a file for reading. We're creating our output file that we're going to write out to. And as long as we can still read stuff in, we're going to go ahead and write stuff out to the output file. Read in from the file, output to the copy. Read in, output, over and over and over again. 1,024 bytes at a time is what this effectively does. Okay, but this is an example of a C program. Figured since I was there, I'd show it to you real quick.
I was writing the Hello World program this time on Notepad. I write like print.out. Like print, I thought it is in my mind, like I write in.
Yep.
And I was like frustrated for 1 hour what is going on.
That's good. No, that's good for you because you want to screw up. I promise you. I have been teaching programming for 18 years. Okay, and I've been programming a lot longer than that. The good programmers are frustrated when they start, visibly frustrated. It's the ones that roll over and say, this is too hard, I can't do it, that end up failing.
It was like small program, so I got like word by word what was going on here.
Yep. And eventually you'll be able to sit down and just pump it out. It becomes an interesting thing. For instance, it's a little bit weird, I think, maybe in this class, because since many of you, English isn't your first language, papers are difficult for you, right? And I get it, but it's the nature of the beast, and it just is what it is. But typically, in an undergraduate computer science degree, where most of my students are Americans, for the first couple of classes, when they're not very good programmers, they want papers. Because programs are their nightmare. But later on, they'd much rather have a program than a paper. Because not that programs are easy, but programs are fun. Because even as seniors, you still find it challenging, but you find stuff like this trivial as a senior in computer science. But, so it's just like a sport, right? When you first start playing basketball, you'd rather watch the NBA on TV because you suck, right? But when you start getting better at something, all of a sudden, when you watch a sporting event on TV, it makes you want to go and play it, right? Like I hate coming up here pretty soon is the Masters in golf, and it's still crappy weather here when they're playing the first major of the year. Well, that kind of makes me want to get out and go. So, all right. So we understand this return stuff. We understand the function stuff. Kind of makes some decent sense. So let's kind of gut this a little bit. Let me do this. Understand we could also write functions that take more than one parameter. So let's say we're going to write a function called int add nums. And this guy is going to, let's say he's going to return, well, let's say he's going to take in an int A and an int B, so two separate values, and we'll return A plus B. What's the output of this program going to be?
Nothing.
Nothing. Nothing. Why?
We didn't call the function.
I haven't done anything main. All programs begin and end with main. I've written a whole bunch, well, not a whole bunch. I wrote a couple lines of new code. Again, this is an untapped resource. But now I'll go ahead and call it. So I'm going to do system.out.println add nums 3, 4. What's going to print out? 7. The result of add nums 3, 4. So 3 will come in for A, 4 will come in for B, 3 plus 4 is 7. We're going to return that value. It'll come firing out of here, so this guy will resolve to the value that was returned, which is a 7, and we can then print out the 7. Okay, but understand that I could have done that. Let's see if anybody was paying attention. So, what's this guy going to print out? 6. So just because it's called add nums doesn't automatically mean it's going to add numbers, right? It's called add nums. It takes in a 7 and a 1. 7 comes in for A, 1 comes in for B. I take 7 and I subtract from it the 1, giving me a 6. So the output of this will be 6. Make sense? So an important thing there, just like our variable names, you should name your functions something descriptive, something that talks about what it does. And notice the naming convention I've been sticking to on these functions that have multiple syllables. Typically, functions start off with a lowercase letter and have an uppercase letter somewhere in them, possibly multiple uppercase letter. Let's say we wanted to write a function that took in 2 numbers and it returned the larger of the 2 numbers. Maybe it's a function called max. So a max is going to take in 2 integers and it's going to return the larger of those 2 integers. So first of all, what's the return type of max? What kind of value is max going to return? An int. So we're going to throw static in there because we're supposed to. Its return type is int. What did we decide we're going to call it? Max. We always have a parameter list in all functions. How many parameters are we taking in here? 2. What kinds of parameters are they? Both of them are integers. What do you want to call them? Okay. Yeah. Well, we could use B. It's not in scope. But we don't know which one's the little and big one.
L and S.
So yeah, XY, num1, num2, something like that. So we can call it int num1, int num2. So we're going to take in 2 numbers. And this guy is supposed to return which of those is supposed to return the larger of those 2 numbers. How do I figure out which number is larger? I need to ask a question. Okay, so this goes way back to slide number 1 or whatever it was. How human beings solve problems. We're remembering 2 pieces of information here. Okay, we have a value called num1. We have a value called num2. Num1 holds some integer. We don't know who's going to call this and what number they're going to pass me. Num2 holds some integer. We don't know what value it's going to hold. We need to ask a question in here. What question do you want to ask? Okay, if num1 is greater than num2. If num1 is bigger than num2, so if num1 is greater than num2, then you want to return num1. Else, return num2. Just like that. Okay, so now I'll take this opportunity to show you something else here. Because we only have one statement following this if statement, I'll write this in a really hard to read way. That is completely equivalent code. formally, well, first of all, the else is not required. Because if I'm still kicking when I get down here, that means I did not return here. Because the return statement makes a method end, right? So if I'm still around, I don't need to go into an else. I could just return this. The else wasn't wrong. Wasn't hurting anybody. Okay? Parentheses are the bigger, the curly braces are a bigger thing. Formally, the syntax for an if statement is if, open parenthesis, Boolean expression, close parenthesis, statement. That is the formal syntax for an if statement. Now, historically, what we do is for our one statement, we use a block statement, which is a collection of 0 or more statements. That's what a block statement is. So if we by default just always put the opening and closing curly brace in there, we could put one statement in, we could put 20 statements in. It doesn't matter, it will never be wrong. But it is optional. So in this case, this is a single statement. So if this Boolean expression is true, do this. This guy is not part of it. Even if I indent him so it looks like it's part of it, he's not part of it. That makes sense? So some programmers would like to do something like this. Sometimes they'll put it up on the same line like that. That's not as bad. You can read that reasonably well. My position is this. It is never wrong to use the curly braces. You will never, ever, ever, ever get into trouble if you explicitly put the opening and closing curly braces in there and put whatever you want to happen as a result of that Boolean expression inside them. Even if it's only one line, it will never be wrong. So don't play the game of using the curly braces sometimes, not using the curly braces other times. Once you understand it, it's not the end of the world. But I'll tell you what, the number of errors you will make will be far less if you just always have the habit of this. When you write an if statement, you write your Boolean, you drop down, opening, closing curly brace, done. Now you're building the sandwich. Whatever you want to put in there is fine. Return num1. That make sense? So if I call max on 7 and 1, I should get a 7, right? If I call it on 7 and 9, I should get a 9. Make sense? All right, so that's the purpose of functions. So now I've written a nice little tiny handy function that I can pass any two numbers to, and it'll just spit back the bigger of the two. No harm, no foul. Now, could I write, this isn't rocket science, right? I could write this if statement pretty easily anywhere in my program, couldn't I? But if I'm having to find the maximum value between two numbers pretty often, wouldn't it be helpful for me to have written this just one time, and then whenever I need a maximum value, just do that? We can start seeing pretty good value for that pretty quickly, right? All right, that's the purpose of functions.
Why these things are not functions are not good as a like in the language that we call it anyways than writing it in the program.
What do you mean?
Like in the library, these functions are already in the library, like max or minimum.
I think max is. Yeah, so I think math.max exists. Does it? Yeah, it takes 2 ints. Yeah, there it is. Math.max. It does exist. Yeah. But we don't know that, right?
Yeah,
You know, and it's not just that. Yeah. So, you know, so you're right. You're right. It seems like a lot of those things should exist. But consider, I've been writing Java since it came out. Since they invented Java, I've been writing Java. And I would say that I probably have seen less than 50% of the language. Because there's so much stuff in Java that I've never had a need to use, right? So there's all sorts of stuff in there that I haven't used, but one of the things we're going to focus in on here is, as probably next class we'll start looking at this, is there's a lot of power in reading the documentation, okay? Just because I haven't done some things in Java, I feel pretty confident that if I knew which object to use, I could use it. That's a skill set. Memorizing the language doesn't do anybody any good. Okay, what's going to end up happening is you guys are building this tool set. So you know a very small little group of things right now. And you have to solve all the problems I throw in front of you in terms of that small group of things. Now you probably can suspect that there's a bigger group of things out there that might be handy. You know, like when you get a foot of snow and you have the plastic shovel and the guy across the street has the tractor. Okay, right? All you got is a shovel. Okay, you're not happy, but that's going to get the job done. Make sense? It's the same thing. Okay, so fine, I have more magic tricks in my toolbox than you have just because I've been messing with this longer. But by the end of this 8 weeks, you're going to have far more magic tricks than you have right now. Because every single assignment, I'm effectively going to say, here's an assignment that's somewhat hard to solve in terms of what you know how to do. Then the next class will solve it, and I'll say, oh, and here's a better way. So I'll introduce a new tool for you. So after you shovel the foot of snow, we'll go out and buy a small snowblower. Not a big one. It's still going to be tough. Okay? but you'll have a snowblower. Makes some sense where we're going with it? All right. So that's our idea of functions. Now let's talk about strings. Strings are among our most powerful power tools in Java. I like to say that Java is a string-based language. And what I mean by that is if we can get something into the form of a string, we can do almost anything with it. All right? We can do almost anything with something in the form of a string. So, what does a string look like? Just like chars, where a single quote followed by a character followed by a single quote, strings are double quote followed by 0 or more characters followed by a double quote. That, for example, is the empty string. Empty strings are very helpful for us. Okay, and I'll show you why here in a second. And I'll actually prove this point about Java being a string-based language. So before I go farther on this slide, I want to talk about something called string concatenation. So concatenation effectively means glue two things together producing a string. That's what it means. We're going to take this, we're going to take this, we're going to stick them together, and now it's a string. That's concatenation. All right? The concatenation operator is going to look very familiar to us. It's the plus sign. That's the concat operator. So, how does Java determine whether we mean to concatenate or we mean to add? Well, it's going to look at both sides. If both sides are numeric, it's going to do addition. If one of the sides is a string, or if at least one of the sides is a string, it'll do concatenation. Make sense? Because we certainly don't want to try to do math with 5 and hello, or hello and world. You know, like hello plus world. We'd probably like that to just get glued together rather than do some sort of made-up math with the Unicode values of hello and world. Now, I mentioned that this is pretty handy for this empty string. And here's a good reason for that. I mentioned a few minutes ago that Java is a string-based language. So output of this program will be 0 to 9, right? This is our for loop that goes through 10 times. Each time through, we're going to print out the current value of I. This is going to be 0 to 9. This is the integer value 0, the integer value 1, the integer value 2. Looks the same, not the same. This is the string 0, the string 1, the string 2, because I took the empty string and I concatenated onto it I. So this produced something that looks like that, or that, or that. Make sense? So in Java, you can turn almost anything immediately into a string by just concatenating it onto the empty string. The empty string has 0 spaces in it. So I just turned an int into a string. And if you believe me that strings are really powerful and I need to do something weird with an int, it might be helpful for me to turn it into a string. Now, what happens if I want to turn it back into a int? Now, when you're working on the 5th part of your homework assignment this week, you're going to really hope, wish that I had just answered the question I asked. Unfortunately, I'm not going to answer that question until next week. That's why your homework is difficult, the last part. You would find it very handy to be able to take a number like that, a string 127, and turn it back into the integer 127. I promise you it's built into the language, but since I haven't introduced it, you're not allowed to use it. So I just covered my butt. So now if you try to use it, you're not going to get points. All right? So I want you to brute force it. I'm going to teach you enough stuff today to be able to do it. All right? This is the shoveling a foot of snow with the plastic shovel. All right, so this is we'll call this the empty string trick. You can turn any primitive type into an empty string by just concatenating, any primitive type into a string by just concatenating it onto the empty string. Okay? Now, more common strings are going to be double quote, hello world, stuff like that. All right, now back here, I mentioned that object types can hold 0 or more values, but they can also potentially do more. They have methods associated with them. Just like we just wrote some of our own methods, strings have some built-in methods that we might find handy. All right. All right, so we're going to look at string methods. I'm going to define them here. I'm going to show you the method header for these, which should tell us how to read them. I'm not going to go into the difference between static being there and static not being there today in terms of the details of it. Okay, we'll see the difference in calling it. I'll go into a lot more detail next week. All right, so for right now, the way you call these is the way I'm going to tell you to call them. All right, so there exists in the string class a method that returns an int, its name is length, and it takes no parameters. And this guy returns the length of the calling string as an int. Okay, we have a method that returns a char called charat that takes an integer index as a parameter. This guy returns the character at position index in the calling string. And that calling string part will make sense to you here in a few minutes. I just want to introduce these guys initially. We have another function that returns an int called index of that takes a character as a parameter. This guy returns the position of the first occurrence of C in the calling string, or, and this part's super important, okay, you're all going to want to hope you listen to this when you're doing your homework. It's not going to seem all that thrilling, but I promise you this next part is the most important part of this function. Or -1 if it was not found, if C was not found. Okay, so the hint I will give you is sometimes when you are looking for something, it's better to find out what's not there than what is there. Make sense?
Back to class
That
one.
-1 thing can be very handy. You might be able to ask a string, do you have one of these guys? And if he returns -1, the answer is no. That might be fairly meaningful to you sometimes. Okay? So, index of is important anyways. Now, we'll look at some examples of it here in a few minutes. So we have length, we have char at, we have index of. Okay? I think those are all of the string magic tricks that I'm going to let you use for the homework assignment. All right, so now let's introduce each of these. So I'm going to say string s is equal to hello. If I do system.out.println s.length, that will be the length of s. Similarly, let me go ahead and give myself a s2, and I'll make s2 equal elephant. All right, so I have two variables. S of type string is equal to hello. S2 of type string is equal to elephant. I'm printing out S's length. This is how we call the string methods. Okay? The reason we're calling these differently than the other ones has to do with that static keyword, but we'll talk about that later. For right now, the way you call a method from a string is you say S, in this case, I want you to call your length method. S's length should return a 5 because that's how many characters are in S. S2, I want you to call your length method, which should return 8, the number of characters in S2. All right, so there's our 5 and our 8. Make sense? Let's look at the nature of strings visually. When we create a string called S and we start it equal to hello like this, what actually gets created under the hood, we're not going to talk about memory yet, but what actually gets created is a construct that looks like this. So even though we represent hello as double quote, HELLO, double quote, it actually gets broken into a bunch of individual chars. The H lives at position 0 in that string. The E at position 1, the first L at position 2, the second L at position 3, the O at position 4. This string's length is 5. That is to say, the length of S is 1 greater than the last legal position in S. So a string with length 5 has legal positions 0 to 4. Make sense? So, if I want to get this E, for example, I have this char at method. I can say, give me the character at position 1, and it will spit me out the char E. Make sense? Well, we've seen the lengths here. So S dot char at 1 is going to get me the character at position 1 in S, which is an E, as opposed to the character at position 1 in S2, which is the L in elephant. Make sense? All right. So let's say that I wanted to write my go-to loop to loop through a string. I can say for int I is equal to 0, I is less than s dot length, I plus plus. Then I can say system.out.println s dot char at I. So that'll print out an H, then an E, then an L, then an L, then an O. Separate lines. So this takes I on a voyage between bucket 0 and bucket length minus 1, because we only go as long as it's less than s dot length. So if length is 5, I will be 0, 1, 2, 3, and 4. Okay? Not 5, because that's illegal. So if I run this right now, there's our hello. If I accidentally put an equal sign in there, we're going to get an array index out of bounds exception. Tried to access bucket 5 of something that doesn't have a bucket 5. Make sense? Okay. I could write a function here. I could say static print string, and this guy could take a string s as a parameter. I can say for int I is equal to 0, I is less than s dot length, I plus plus, system.out.println s dot char at I, and this guy's going to return nothing. How many characters are in S? How many characters are in S? Based on what we've talked about in the last 10 minutes.
1, 0.
Remember, this is a function. Purpose of a function is we can write it once. It's an untapped resource until we call it, and we can call it multiple times. How many characters are in S? There's S dot length number of characters in S.
Like 4.
No, S dot length.
Okay. Alright.
If I passed it hello, it would be 5. If I passed it elephant, it would be 8. If I passed it some 4,000 character long string, it would be 4,000. The number of characters in S is S dot length. That's the beauty of a function. This guy can take in any string, and I can tell you how many characters in that string simply by just saying S dot length, number of characters. I will just ask that string to tell me how many characters he has. Because I have no idea, at the time I'm writing this function, I have no idea what kinds of strings people are going to throw at me. The reason I wrote this function is so I can print out all sorts of different strings. Strings that might be length 3 or 4 or 5 or 20. Doesn't matter. Make sense? That's the purpose of a function. So we want to start wrapping our mind around the idea that this is a definition. This is an untapped resource, which means that we don't necessarily know the nature of the values that are going to be passed in other than their type. All we know here is that S is going to be a string. That's all we've governed. We've said, if you try to pass me something other than a string, I bet you Java screams at you. But as long as you give me a string, I'll take it from there. So now it's going to be on us to figure out, okay, well, how long is that string? Because I only want to go through starting at bucket 0, because I know every single string starts at bucket 0, and I know its last legal bucket is its length minus 1. Make sense? All right. So now I have this print string. I should be able to print S and S2. using that exact same function. S happens to have a length of 5 in this case. So this S will get passed into this S, which has a length of 5. This S2 will get passed into this S, which will have a length of 8. So this will print out those two strings. Make sense? All right, so that's charat, and that is length.
So we didn't need return.
I'm not returning anything. I said void, and it's printing it, not returning it. I'm not printing it up here. Yeah. Yeah, you got confused because I said print. Yeah, I'm not doing system.out.print. It just happens to be called print. Yep, that's the name of my function. So here's this last one, index of. You will find this one extremely helpful for the first 4 parts of your homework assignment. And once you figure out one of those 4 parts, the other ones will be easy. But man, you're going to bang your head on the wall to figure out the first one, or the second one, or the third one, or the fourth one, whichever one you figure out first. And all the other ones will be easy until you get to 5, and then you're just going to cry yourself to sleep.
It's usually happening from last 3 weeks.
What's this?
It is usually happening from last 3 weeks.
Yeah.
Like, wake up.
Yeah. All right. So let's look at index of. As I've advertised here, index of returns the position of the first occurrence of C in the calling string, or -1 if it was not found. So for example, the first occurrence of H is 0. The first occurrence of E is 1. The first occurrence of L will be 2, even though it occurs in both 2 and 3. See, it returns the first occurrence. First occurrence of O is at 4. So if I say system.out.println s.index of H, I'll get a 0. H first occurs at position 0 in that string. E first occurs at position 1. L first occurs at position 2. O, position 4. W, -1. That's the important one.
It's checking to see if it's telling you that it doesn't have it.
Yeah, -1 means I didn't find it. Where was the first position of W inside of S? It wasn't there. That's where the first position was. Okay. If I change this to S2 and I say I'm looking for an A, it's going to tell me it's at position, what is that, 7, 6, 5? So 5. It makes sense what index of does?
And that -1 is a hint.
Well, -1 means it's not found. So if I look for a W inside of elephant, which it's not there, or here, I'll look for a question mark inside of elephant, also not there. Okay, I see no question marks here, right? So if I look for a question mark inside of the string S2, it will return for me the value -1. It's not an error. It's telling me I didn't find it. -1 is how index of lets me know that he did not find it. Very, 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 very important. All right. Now, let's kind of complete this lesson for what we need to do for our homework assignment by seeing a practical use of concatenation. Okay, so we've seen kind of the trick concatenation. Empty string, concatenate onto that anything, and now it's a string. So now I can ask what the length of it is. I can ask the character a character at a certain place, things like that. But what if I wanted to write a function static string reverse. So what I want to do is I want to take a string in as a parameter, and I want to return the reversed version of that string. Okay? So strings cannot be modified. They are read-only. We can add on to a string, but that ultimately produces a new string. But I cannot remove stuff from a string without building a brand new string. You will find that last statement extremely helpful on your homework. We cannot remove things from a string without building a new string, keeping only the things that we are supposed to keep, rather than removing the things that we don't want. Make sense? So we're going to build, since I want to take S, whatever S is. So S has a length of S.length, right? That's our drill, okay? So whatever S is, I want to return ultimately a brand new string that is whatever S is, but backwards. So I'm going to create a string answer, start that off as the empty string. That's my building block. I'm going to build a brand new string in answer by concatenating on individual characters from S in the right order. So what I'm going to do is I'm going to walk S from the end of it towards the beginning of it. What is the last legal position in S? That's my Twitch face. Not 4. We don't know the nature of S. This S right here. What's the last legal position in S? S.length minus 1. The last legal position in S is S.length minus 1. What's the first legal position in S? 0. Always 0. So we're going to write a nice go-to loop for int I is equal to S.length minus 1. Keep going as long as I is greater than or equal to 0. Subtract 1 from I each time. So if S had a length of 5, this will take us from 4 to 3 to 2 to 1 to 0. All right? At each of those places, I can go ahead and get the character at that position. And how do I get the character at that position? I say s.char at I. This will boil down to the char that lives at position 4, then position 3, then position 2. This will get that character from there. And what do I want to do with it? I want to tack it on to answer. I want to concatenate it on to my answer. I'm building on to the empty string one character at a time by walking my original string in reverse. In the end, I can go ahead and return answer. And now I should be able to say reverse S, which is going to pass hello into my reverse function, which is going to go and build up hello in reverse. And this guy's not printing hello in reverse, he's returning a string. So this ultimately will boil down to the string that is the reversed version of S. S has not been changed. I'm given a brand new string that happens to be the reverse of S. So there's hello in reverse. If I pass this guy S2, I would get elephant in reverse. Make sense? All right, so now, as a reminder for you guys for your homework, I'm going to go ahead and I'm going to check this in to GitHub, and then I'll go and I'll modify your homework assignment to paste my link in there so you have this as a starting point to reference. All right, so for those of you who had trouble with GitHub this last week, pay attention. All right, so I'm going to start off I'm going to go to the GitHub website. I'm signed in or whatever. I'll go here. I'm going to create a new repository. And we're going to call this guy CSC535 Spring 2016 Week 3.
Can we add to the same repository?
We can, but it'll be easier for you to see them separate. I certainly can add it to the same thing. But then I have to start talking about branches in a repository, which enough people had problems with the repository to begin with. Let's keep it completely separate. So I'm just going to call this guy week 3 code. All right, so this is week 3, right? All right, so that's going to be the name of my repository is that guy. So I'll go ahead and create that repository right there. So I have this brand new thing. So what I'm going to have to do, I've already done my git init. I've already done most of the stuff. The thing that I need to redo is this part for me. All right, so I'm actually going to do the whole thing just to prove it to you. So I'm going to go out here to for me, it's a terminal. For you guys, if it's on a Windows machine, you'll double click on init, which will give you a terminal. Okay, so we're going to move into the directory where that guy lives. So that's, for me, that's in Dropbox. Here, actually, the easiest way for me to get to that on a Mac is I'm going to go ahead and pop open my Dropbox. I'm going to go to the folder where that guy lives. And that is this guy, right? That's the source folder. So I'm actually going to take that source folder and just drag it into the terminal here. And put it after CD, so that's the full path to where it was. Easy way to get to that that place.
Windows users can with 4 GB RAM can do that.
I don't think you can drag a folder in there, but you can do a CD. Just get to the point where you're sitting in the directory where it is. All right. So if I do an ls-a, I see I still have my Git repository there, but I'm going to do an rm.rf.git. All right, so I no longer have a Git repository for this guy anymore. So this is as if you just started from scratch. Okay, so I'm going to put this on Git right from the get-go. So I'm going to go in here, go back to Git. I'm going to copy this one line at a time. So there's a Git init. So it initialized an empty Git repository. The next thing is this README. I usually skip that. The next thing I'm going to do git-m commit. This is my first thing. All right, so this guy's saying that, oh, you had untracked files. So I'm going to have to do a git add star.java. So this adds all the current files. Now I can do a git commit, and this has now committed that one file to the repository. Now this next line, I only have to do this once per assignment, if you will. So I'm going to go ahead and do a git remote add origin, and this links it directly to this Git repository. And then finally, this last one, git push-u origin master. Now it should be up there. So if I click on this, I should see my driver.java, which has all this code in it. Make sense? So I'll go to your assignment in here. And I will paste that link for a starting point so you can look at my sample code. But I think I did mention last time, and I'll mention it again, try not to copy and paste too much code. Give yourself the opportunity to make typos. I know it sucks, I know it pisses you off, but I promise it will benefit you. All right. All right, so under assignments, the new assignments are up. One of them's a paper on problem solving as it relates to technology. Discuss when it's appropriate to use existing tools like Excel to solve a problem versus writing your own software to solve a problem. So one thing we want to consider in here is the right solution isn't always to write a program to solve the problem. Sometimes we want to consider that, oh, the software I need actually already exists. Or the software I need mostly already exists, and I can maybe just supplement it with something else. So explore that idea as the writing thing. Here's the programming assignment. So number 1 is print vowels. So you're going to take a string in. This method should take a string as a parameter and prints all the vowels in that string 1 character per line. Okay, well, I've shown you plenty of things where we've had 1 character per line printed out, but not just the vowels. All right, so it would be like H-E-L-L-O is 1 character per line, except you shouldn't have the E or the O. So just H-L-L is what should actually print out. Print consonants, print digits, those are numbers, 0 to 9. And this last one is process expression. This is the one that sucks. This method should take a string in the format of some integer, followed by either a plus, minus, times, divide, followed by another integer 0 or more times. Your method should then process this expression and return the result as an integer. You must solve this problem using only the tools we've used thus far. So if you took in the string 125, it should spit out the integer 125. If you took the string 125 plus 7, this should spit out the integer 132. So on and so forth. You do not need to worry about order of operation. Just go left to right. Make sense? Okay. That's a hard problem. All right, so last one, 125 times 2 should give you 250. 125 plus 7 minus 2 should give you 130. You're doing the math from left to right. All right, I'll go ahead and edit this and put my link in as a starting point. Code from class as some examples. All right, questions, comments, concerns, bribes. All right, I will see everybody next Wednesday.